Oh, hello. This is a test of whether or not we can begin to bring a little bit more interactivity into the science debate in Boost Loft. So I'm just going to spend just a few minutes talking about some really interesting science. And also at the end, I'm going to tell you how the stolen whiskey, 11-year-old bourbon is. And I will be occasionally sipping that through this video from glass with the wonderful Science Debate and Booze Loft logo on it. So this is a hell of a ride. I found this to be very, very interesting. So let me get a little bit started here. So the new issue of Science magazine came out today, and it is the 25th of September 2020. And the way Science magazine typically likes to run is they'll have the research, they'll have the reports, but also they will put forth sort of a summary and sort of an impact kind of article. So if you want to, you can read just the impact and get an idea for what really is going on, but maybe you don't want to read everything. But in this case, this was interesting. I did read the summary. I did read both the articles that were written, and they do concern birds. Now, for those who don't know, my wife and I, we have two birds, Sydney and Darwin. And how they got their names is a completely different story, but we'll get in that here. But anyways, let's talk about what this is. There's apparently been a lot of controversy around, do birds actually think? So that phrase, bird brain, being stupid. Not necessarily being stupid though, but being very, very simple-minded. Where decisions literally come down to like one of three or four things that you do: fly, stay, eat. Well, sorry, if it's sniff it, lick it, fuck it. That's a dog. That's the only three options they have. But there's a reference in this to two good pieces of science. One is on page 1585 of the issue. The other, that's by Stacho and his colleagues, and the other is on page 1626 by Nieder and his colleagues. And taken together, they really do kill the idea that birds don't think. I mean, they present very convincing evidence that birds think, and they do this in a very different way, not through the typical psychology way of presenting tests and saying, well, they had to think, because those tend to be incredibly, incredibly fucking subjective. They did it through comparative anatomy and basically looked at the brain structure at both a macroscopic and microscopic level and said, okay, is this indicative of something that would be thinking? And so the idea here is that a lot of folks didn't think that birds, or at least the majority of birds, had a cerebral cortex. And it turns out that pretty much to be a bird, you have to have a cerebral cortex and you have to have the genes that will provide the brain structure and the organization to have a cerebral cortex. So, and it's not just that it has a cerebral cortex. It's okay. That first sip was not what I was expecting. But okay, so the interesting thing about the cerebral cortex in the brain of a bird, and most birds, and especially corvids, the super super fanciful, they're black. Ravens and crows, that's what the fuck corvids are. They're very similar to mammals in a lot of ways. And a lot of us, those of us who believe that, of a single evolutionary tree, which you have to be an idiot not to, we have a common ancestor. So, but at some point, where on these things would brain structure diverge. And it turns out that between mammals, birds, dinosaurs, all those other things, you go back down, we're probably closer than we think that we are. And that's why this comparative anatomy was actually so important, because it turns out that there's a lot of brain structure similarities in terms of how the cerebral cortex is laid out relative to the hindbrain and the midbrain, the thalamus and the hypothalamus, but also that the cerebral cortex is specialized in certain regions for, like, hearing, decision making, and visual processing. So you got this thing in this region here called the pallium, and the next big test was, is it distinct from the hindbrain, the midbrain, the spinal cord? And the answer is yes. Yes, it's very, very distinct. And so you have another section of the brain that is different from the alligator brain. Okay, if everything was just by instinct, you would not need a cerebral cortex. You just need an input that leads to one of 3 or 4 decisions, and an alligator brain can handle that. Okay, that's simple, 2 or 4 factor binary decisions. Okay, so the fact that it's distinct and can pull information from the hindbrain and the midbrain tells us that it is a fairly advanced structure, and that's what you would expect of something that might or should be able to think. So the next question here is, really, if you have something that is similar in structure to the human brain, has a layout that's similar to the human brain, but yet still we believe is much, much simpler, because they don't have the level of intelligence that we do, or that other things that we know to be intelligent are. Does this mean that they are true thinkers? And some people would say, do they even have consciousness? And this is sort of where you get to look at the data and put it into your own context and say, okay, this is what the science says, and the science is good. I mean, what they're saying in terms of layout and structure, the comparative, I mean, it's really, really good. But now let's take a look at the conclusions, and that's a little bit different and requires a little bit more history to really consider. So let's take an idea of where you have fundamental processes that handle sort of a baseline level of functioning, okay? And through those processes, you handle everything that you need to live or need to function, but also serve to provide a baseline level of information that other parts of a brain or a process can pull from. And so that separation of baseline function, advanced function, that was probably one of the biggest leaps in computer science when we started programming, building computers to function in that way. So this is beyond transistors, within the second generation, integrated circuits. And from there, you start getting to very, very specialized functions with increased memory capacity, how you handle that memory, and you get very, very specialized. That's actually kind of very similar to how the hindbrain and the cerebral cortex works. It's not exactly that, but it's similar. The hindbrain and the cerebral cortex is much, much more complicated, and there's a lot that we don't understand about it. But there are this thing that in the back of your head that you're saying, well, if the brain has specialty functions, then from a computer perspective, I can build something that will handle those specialty functions, and I can easily incorporate it into the advanced layer, i.e. the cerebral cortex, either as an add-on or directly into the CPU. And depending upon how much power you need and what you needed to do, you will design it accordingly, and it'll either be inside or it'll be out, depending on what. And this is kind of like having a super powerful graphics card connected up to a really, really great camera so that you can get the best pictures you possibly can, which is not what we're doing here on this first test. But the second thing that really makes me wonder is that when you look at birds in this remarkable similarity to the human brain and how it's laid out, and I look at that and I look at one of the most widely studied neural model ever, which eventually people want to get to, which is the human brain. And people have laid out neural networks in many, many different ways, trying to make sure that they have this. They try to get closer to that model. By the way, my computer screen just briefly flickered off because this is taking way too long. But we're almost there, almost where we need to be. So you have an animal brain that's built like a human brain in terms of structure. You have a model. It's a very, very simple model, and really we can make very, very strong correlations in terms of structure of the avian brain, the bird brain, not just to the human brain, but also to how, at least at some level, these computers can work. But when you get back to neural networks, these very simplest nodes for neural networks oftentimes give you the best results. And the idea of being simplistic and building these neural networks. And once you talk about being simplistic, then you talk about being small, and suddenly you can put neural networks into a very, very small space. Now, this is important because when you put all those things together, it meshes really, really well with something we already know, and it's an absolute truth that, they've done some really great science here, Stracco and Nieder. But it may be for naught because we know that birds aren't real. They're drones. We're humans. We built them. We're using them to spy on people. So everything that they've seen makes fucking sense. Of course it's going to be that way. Why wouldn't it be that way? We're building them like us to do things for us. So it makes perfect sense that they got this on as they did. And it makes perfect sense when you know that birds aren't real.